Sometimes there won't be any proper mathematical models for some signals. At that time, the graphical way of convolving two signals or finding out the convolution of two signals will help us to resolve the problem and reach to an answer. So that is known as graphical interpretation of convolution. In this video, we are going to discuss about the graphical interpretation of convolution integral. This will help us to solve many problems which we face in the subject signals and.
Now let us try to understand the graphical interpretation of convolution operation. What is the graphical interpretation of the convolution operation? For that, let us consider this convolution x of t into g of t. I am trying to convolve two signal x of t and g of t. The x of t is given here. It is a kind of step signal which is starting from -1, and here g of t is a kind of exponentially decaying signal which is starting from -2. These are the two signals which I have to convolve. We know that the convolution integral is given by -infinity to +infinity x of tau g t minus tau d tau. Now we have given x of t and g of t. We have to find out what is x of tau, what is g of t minus tau. Then we have to multiply it. Then we have to integrate it over the limit -infinity to +infinity to get the integral. Now what is the graphical meaning of this? First I have to obtain x of tau and g of tau, right? So simply by replacing the axis t by tau, I will get x of tau and g of tau. You have to note that the shape of x of tau and g of tau are exactly equal to x of t and g of t. The shape of this is x of t, this is g of t. The shape of x of tau and g of tau are exactly equal. Now we are not satisfied with that. We have to find out g of t minus tau. We have to find out g of t minus tau. For this, first we have to reverse g of tau. So if I reverse g of tau, what happened? I have to horizontally flip it. So when I horizontally flip it, this -2 portion, this line will go to +2 and it will become an exponentially increasing signal like this. So this is the flip I have performed. So after the flip, the name of the signal is g of minus tau, g of minus tau. It was g of tau, this is g of minus tau. Our x of tau is there, still there. Now I have to find out g of t minus tau. So for that I am trying to shift the signal to the right side. Shift the signal to the right side, right? So for a reversed signal, shifting to the right side means advancing the, I can write it like g of minus tau plus t. I am trying to advance the g of tau signal by t time, right? T time. So this is equal to g of t minus tau, because tau is negative and t is positive. So I can write it as g of t minus tau. So if I shift this signal to a location which is equal to t, right? Then I will get signals x of tau and g of t minus tau. So that is represented in this particular diagrams like this. When I move to the right side, I will get g of t minus tau, right? So here you can see t1, this is the distance t1, this is the distance t1 which is greater than 0, then my g of t minus tau will go to the right side, right? If my g of t minus tau in which t is less than 0 or t2, this distance t2 is less than 0, then it will go to the left side. Now I have to multiply this signal up to this with our step kind of signal. We have to multiply with this signal, right? And when we multiply this, you will get this much area. Similarly, in this case, in the second case, if I provide t, this t less than 0, my signal g of t minus tau will be moving to the left side of these two, and here it is moving to the right side of the 2, and here it is moving to the left side of the 2. Now also I can multiply this signal up to this and this signal up to this, right? So this will be the product, this will be the product. I will get this much area, right? So I am going to call this area as A1 and this area as A2, right? And I will be marking all these areas on a graph. For example, this is A1, this is A2, this is A1, this is A2 for two different time t. In the first case, time t was greater than 0. In the second case, time t was less than 0. Now I am going to take another case of time t which is less than minus 3, which is time which is less than minus 3. My signal g of t minus tau will move to this location, and if you carefully observe, you can see that there is no overlap between the two signals. There is no overlap between the two signals, and if you take the product, or if you find the area, right, if you find the product or area will be equal to 0. So at the location t3, that is this much distance, the product is equal to 0. So you will get 3 points like this. One point is for t1, another point is for t2, another point is for t3 on the CT axis. So what is the CT? CT is the convolved output, convolved signal or convolved result signal, right? So you will get 3 different values for these 3. Now if I perform such kind of operation for all the values, right, from minus infinity to plus infinity, right? So minus infinity to plus infinity, x of tau into g of t minus tau d tau. What happened? I will get the response for all these points, right? I will get the result for all these points, and that is equal to C of t. That is the convolution result. So what I have to do is that I have to reverse one signal. The reverse signal I have to move in the x-axis from minus infinity to plus infinity, and I have to mark all the products A1, A2, A3 like that on this graph, which is known as the convolution output, to get the C of t. So this is how we perform the graphical convolution operation. Now we can see what this is corresponding to area A1, this is corresponding to area A2, and this point is corresponding to the area of the point T3. Now we can see 3 animations which will make the idea of graphical convolution very clear, right? So we have here 2 signals. So this is f of t. So f of t is equal to 1 for t greater than 0. F of t is equal to 1 for t greater than 0. So that is what the red color signal here, right? So f of t is equal to 1 for t greater than 0. So this is our f of t. And what is g of tau? G of tau is e power minus t. So e power minus t means it is a exponentially decaying signal. It's an exponentially decaying signal. So in the graphical convolution, what are the things I have to perform? I have to reverse this signal. Okay, I have to reverse the signal g of tau, right? I have to reverse the signal g of tau. Here you can see I have reversed the signal. This green color is the reverse signal, and I have to overlap these 2 signals, and I have to move from left to right, that is from minus infinity to plus infinity. I have to move from left to right in the from the minus infinity to plus infinity. And these overlapping areas, you can see the overlapping areas here. This is the overlapping areas, and I have to mark the values of that all overlapping areas on the graph, which will give you the convolved result for me. So this is the convolution output. This is the convolution output C of t for these 2 signals.